Okay, let's jump right into this explainer. Today, we're demystifying what is honestly a massive collision course. We're looking at exactly how we go about merging the incredibly messy, highly contextual world of human law with the rigid, absolute execution of machine logic. It's this epic struggle between human nuance and mathematical certainty. And spoiler alert, the solution is going to fundamentally change how we govern our digital world. Let's kick things off with a number that's pretty staggering, 250,000. Just let that sink in for a second. That figure represents the estimated number of active, overlapping patents covering just one single modern smartphone. Think about that. That's 250,000 individual legal protections touching literally everything, from the antenna all the way down to the pixels on your screen. And that right there perfectly captures the chaos of unstructured human rules. Economists like Carl Shapiro over at UC Berkeley call this a patent thicket. It's this dense, almost impenetrable web of overlapping IP rights. And instead of actually fostering innovation, it acts as a legal minefield that blocks perfectly viable inventions from ever reaching the market. It's kind of the ultimate example of human law creating a systemic gridlock simply because it lacks a clear computational structure. To even begin to fix this chaos, we first have to wrap our heads around a grand philosophical clash at the very heart of how we interpret rules. It's the Canadian living tree doctrine on one side and American strict textualism on the other, two totally opposed approaches to how a society should decode its own written rules. On the first side, we have the Canadian living tree doctrine. Lord Sankey famously articulated this back in 1929, arguing that the law is, quote, a living tree capable of growth and expansion within its natural limits. Basically, it adapts incrementally to fit the really messy, constantly evolving reality of society. It's organic, it's human-driven, and highly adaptable. We can think of this as the wet code of human governance. Then, on the complete opposite end of the spectrum, is strict textualism. This is a philosophy heavily championed by figures like Justice Antonin Scalia. Its premise is absolute. It says a statute means exactly what the text says, period. The goal is to execute the text flawlessly as it's written, without injecting any subjective, messy human intent or outside historical context whatsoever. But here's the thing, real life just isn't a neat math equation. Take a look at these indigenous activists marching in Copenhagen back in 2009 during the climate talks. They were fighting for deeply contextual rights, things like the protection of indigenous sciences, medicines, and cultural traditions. These are profoundly complex, very human issues that simply can't be quantified or adequately protected by cold, rigid, strictly literal rules. And you know what's fascinating? This exact legal clash perfectly mirrors a foundational divide in computer science. We've got the wet code of our human minds, what researchers sometimes call OS alpha. It's fuzzy, associative, completely meaning-driven. Pitted right against it is the dry code of ALU fidelity. That's the simple, unyielding arithmetic logic unit inside a computer chip that operates purely on strict electrical voltages. So what does strict textualism actually look like in the tech world? Well, it looks exactly like cryptographer Nick Szabo's concept, the vending machine primitive. This is the ultimate ideal for a pure smart contract. You put $1 in, a soda comes out. There's absolutely zero human judgment, zero nuance, and definitely no judge sitting inside deciding if you actually deserve that soda today. It is ruthless, digital formalism. So how on earth do we successfully merge these two alien worlds? How do we marry the wet, contextual human law with the dry, strict execution of a vending machine without causing a catastrophic system crash? Well, we needed a breakthrough. And inventor Kyle Smith created this unified architecture known as the Hierarchical Script Database, or GRIDB. It uses a JSON-like tree structure, essentially a nested digital filing system, to put static data nouns and active logic verbs right next to each other into single, unified nodes. At the very core of this new database structure is a mathematical concept called the syn kernel function, which stands for thesis, antithesis, synthesis. I really want you to picture this as an uncompromising, super strict, logical bouncer standing right at the front door of your digital ledger, ensuring absolute deterministic fidelity. Here's exactly how that digital bouncer works in practice. Step 1. It sequentially checks the JSON state tree just to see if the database space is empty. Step 2. If it is empty, it synthesizes the new data directly into that open slot. But step 3 is the kicker. If data already exists in that spot,
The bouncer firmly and violently rejects the input. It completely prevents accidental overwrites unless a developer comes in and explicitly forces a manual override flag.
So the really crucial question here is what happens when we take this strict, unforgiving digital architecture and apply it to something as messy as the law? We get what's known as the legal DOM. It's essentially a digital skeleton for the law. Instead of treating a law as a flat, dead wall of text, it uses global XML standards like a Komentoso to turn a statute into a hierarchical, programmable family tree. It literally turns static prose into live, actionable data. To actually pull this off safely, the legal DOM uses what's called the FRBR hierarchy to translate fluid human intent all the way down to the machine level. It tracks a law starting with step 1, the work. Let's say the raw abstract idea of setting a speed limit. Then step 2, the expression, the specific English translation of that rule. And finally, step 3, the manifestation, which is the actual rigid XML file sitting on a server somewhere. It securely anchors a fuzzy legal concept right into a concrete digital reality. But wait, here's the multi-million-dollar problem, right? If this XML is so unbelievably strict and unforgiving, how on earth can a human lawmaker actually draft or edit a law without breaking the entire mathematical system? I mean, you simply can't expect a politician to write perfect schema code just to change a comma in a bill. The system would grind to a halt immediately. The answer is just a brilliant piece of architecture known as the BIDOM synchronization pattern. It solves this huge problem by running 2 entirely separate document layers simultaneously. On the left, you have the editor DOM, which is a lightweight, super intuitive visual interface for the human, but hiding right behind it is the stored DOM, the structurally rigid, schema-validated XML that holds the exact mathematical truth. Let's break down exactly how this translates fluid human intent into deterministic machine execution. Step 1, a human types naturally into that user-friendly visual editor. Step 2, an invisible edit capture extension silently grabs those precise differences and encodes them into coordinate formats. And step 3, those coordinates instantly and securely rewrite the rigid background XML. The human gets to act human, and the machine gets its perfect, unbroken math. This beautiful synchronization pattern acts as the perfect semiotic bridge. Structured text serves as the exact deterministic interface. It flawlessly compiles our messy, organic, associative human imagination right into the unyielding physical, electrical behavior of computer hardware. It's quite literally how we trick rocks into thinking using lightning and text. And ultimately, this brings us to the core takeaway of this explainer. No matter how advanced the database gets or how strict the textualism is, human intent is absolutely irreplaceable. The system still requires the sweat of the brow from a human pilot to orchestrate the truth, to actively bend that rigid, deterministic script toward a moral human mandate. So, as we increasingly try to automate the rules that govern our society, I want to leave you with this really provocative question. If we build systems that attempt to completely remove the human author, who actually takes responsibility when the code inevitably breaks reality? Are we really ready to hand over the living, breathing context of justice to a digital vending machine? Definitely something to think about next time you hear someone claim that code is law. Thanks so much for joining me on this explainer. Keep questioning the code, and I'll catch you next time.